Okay, so the next little video in my series here, we're going to look at glycolysis. So glycolysis will occur in the cytoplasm of the cell, and it's going to begin with glucose. Now, I did not write C6H12O6 out again. I'm just writing glucose. But we do want to keep up with the carbons. We're going to see what happens to those carbon atoms as we go through this process. Remember, I said earlier that the carbon ultimately is going to be removed and will become carbon dioxide. So we're going to see in what steps that takes place. So this first step is called glycolysis. And if you look at that term, glyco indicates glucose. What do you remember? What did we say lysis means? Lysis means to split. So that's exactly what glycolysis is doing. Glycolysis is the splitting of the glucose molecule. So literally in glycolysis, it's going to take a series of reactions, but we don't care about all those reactions. We just are looking at the general process involved. And what will happen is glucose will be split. So when I do this, I like to draw an arrow splitting. The molecule of glucose will be split into two molecules of pyruvate. Now, pyruvate can also be called pyruvic acid. I'm going to write pyruvate because it's shorter, but it can also be called pyruvic acid. So it goes by both names. Each molecule of pyruvate contains 3 atoms of carbon. So we have produced 2 molecules, each that have 3 carbons. So we started with 6 carbons. We're ending with a molecule that has 3 and another molecule that has 3. So did we produce any carbon dioxide in glycolysis? Or another way to ask that is, did we remove any carbon? No, we didn't, right? Because they're all still accounted for. We have 3 here and 3 here, so that means we still have 6 carbon atoms. So we do not produce any carbon dioxide in glycolysis. So this step, again, if we were going to label this, oh, hang on, there we go. This step is called glycolysis. And it's going to produce 2 molecules of pyruvate. In this process, and I'll show you when we go back to our PowerPoint where this happens, but throughout this process we also produce a small amount of ATP. We will produce 2 molecules of ATP in glycolysis. We also harvest some hydrogen. So as this molecule is being split and rearranged, we will pull out hydrogen and we will reduce 2 molecules of NAD. So that means we will produce 2 molecules of NADH, which really means we've harvested how many hydrogen here? Well, that's 2 hydrogen per molecule of NAD, since we have 2 NAD molecules that have been reduced. So we have 2 NADHs. That means we have harvested 4 hydrogen, right? Because NAD will accept hydrogen 2 at a time. So if we reduce 2 of them, that means we've harvested 4 hydrogen. So ATP, 2 molecules of ATP is considered a product. 2 molecules of NADH is also considered a product. So that is glycolysis in a nutshell, and that's all you really need to remember about glycolysis. So as we go into the next step, what goes into the next step are these pyruvate molecules. These 2 guys are going to go into step 2.